All right, let's try to show you a couple of additional things that we can discover here. We can look at our double angle for cosine, and there's a couple other versions that we can use that can be useful for us. And to find those, it's helpful to remember a Pythagorean identity that we had earlier. And so sine squared theta plus cosine squared theta equals 1. I can rewrite that in terms of sine squared theta if I wanted to. And how that is helpful for us is I can go back and look at my double angle for cosine and rewrite that in terms of cosine all the way through. So I can say then that becomes cosine of 2 theta equals cosine squared theta minus sine squared theta, which we now know can also be 1 minus the cosine squared of theta. And then reducing that down, that equals cosine squared theta minus 1 plus the cosine squared of theta. And that equals 2 times, or 2 cosine squareds, theta minus 1. So given that, I have another angle that I can use. I can call this one the cosine of 2 theta equals 2 cosine squared theta minus 1. And then using a similar process, which I'm not going to do right now, I have another one, which is the cosine double angle of cosine of theta equals 1 minus the sine squared of theta. And how you derive that is roughly similar to how we derived the previous one. So let's look at using these new tools to help us solve some identities. And so the identity that I want to look at is the cosine of 3 theta equals 4 cosine cubed thetas, 4 cosine minus 3 cosine theta. So there's the identity that I want to go ahead and verify. And in doing that, remember, we always try to figure out the left or the right side and which identity or which side was the more complex. Well, looking at this one, they both look complex to me. So let's look at the left side. Given that I know I want to rewrite this as 2 theta plus 1 theta. And so if I can remember what that looked like in our previous section, I remember that expanded out to be the cosine of alpha times the cosine of beta, which in this case are 2 theta, take away the sine of 2 theta, or alpha, which is 2 theta, and the sine of my beta, which was a theta. So I just used the previous model that we had in our previous section and rewrote the cosine of 3 theta as this. Okay, what I notice in this is that I see a couple of identities that I can use. I see the cosine of 2 theta, and I see the sine of 2 theta. Well, cosine of 2 theta, I can either use this model, or this model. And I'm going to choose this model right there to begin with. So let's rewrite that as 2 times cosine squared theta minus 1 times the cosine of theta minus sine 2 of theta, which expands out to 2 sine theta cosine theta. Okay, I think I got everything in there that I had. So what I need to do next is just keep plugging away. So let's go ahead and multiply this all the way through. So that gives me, I can't do that because, yeah I can. This gives me 2 cosine cubed of theta minus cosine of theta minus, I had another sine of theta up here. Let's combine those two sine theta. So I have 2 sine squared of theta cosine of theta. All right, so where can I go from here? My sine squared of theta is I can find out where it is. I have a sine squared of theta, and I remember from one of my identities that the sine squared of theta equals 1 minus cosine squared. Now let me try to remember where it is I want to go here and keep track of where I'm ultimately wanting to try to get to. So let's just try. 2 cosine of cube theta minus cosine of theta minus 2. Sine squared of theta was 1 minus the cosine of squared theta times cosine theta. I can go ahead and reduce this part down a little bit. So this becomes, again, 2 cosine cube theta minus cosine theta minus 2 times 1 times cosine theta. So minus 2 cosine theta times minus 2 times cosine theta gives me a minus plus a 2 cosine cube theta. And then from there I can go ahead and add my like terms. I have like terms here. I have 2 cosine theta plus 2 cosine cube theta, which gives me 4 cosine cube thetas. Minus cosine theta, take away another one, gives me minus 3 cosine thetas. And that was the identity that I was trying to verify a little while ago. Whew. Was that a journey? And I had to stop and pause several times just to figure out what am I going to do next, where I'm going to go next. And I don't know. What do you guys think? You guys think I did all right?
Yeah.
You want to come in and say hi? You like that? Yep.
Hi.
Say hi up there. You got to jump up high. Jump up
Hi.
high, Chase. All right.
Hi.
This is my audience that was watching this video, and so they're learning trigonometry just to right along
What's
with you guys.
trigonometry?
What's trigonometry?
Yeah.
I know. We're going to wait and find out.
And what's